I want you to visualize walking into a premium commercial office tower. Just picture any major financial district.
Right.
You pass through those heavy revolving glass doors, and immediately you are standing in this sprawling, multi-story atrium.
Oh, yeah, the really intimidating one.
Exactly. You're looking at polished marble floors, custom architectural lighting, maybe a massive security desk clad in granite, and a whole bank of 12 high-speed elevators wrapped in brushed steel.
It's an undeniably impressive space.
It is. It's an intentionally awe-inspiring spatial experience.
Mm-hmm.
But as you stand there, waiting for your elevator to arrive, I want you to consider a completely different layer of that reality. A question that almost no one, well, unless they're actually writing the checks, ever bothers to ask. How exactly do they decide what to charge for all of this?
It is arguably the defining question of the entire commercial real estate industry.
Right.
And the answer is completely disconnected from the physical act of just laying a tape measure across an empty concrete floor.
Yeah, it's not that simple.
Not at all. You aren't just paying for the dimensions of the room where you put your desk. You are paying for a highly calculated, meticulously distributed piece of that entire vertical ecosystem.
Okay, let's unpack this, because this is exactly why we're pulling apart this topic today. When you look closely at commercial real estate, there is an invisible, three-dimensional geometric grid superimposed over every single building.
Invisible, but very, very real.
Very real. It's a strict system of rules, definitions, and mathematical multipliers that dictates the financial reality of every square inch of commercial space. So for this deep dive, we are examining a set of essential guidelines. Specifically, we're looking at excerpts from the BOMA measurement standards for commercial real estate.
The industry Bible, essentially.
Yeah. And our mission here is to decode the hidden math. We are going to deconstruct exactly what a business is legally paying for when they sign a commercial lease. We'll look at how the costs of those massive, beautiful, common areas are actually distributed among the tenants, and how a single, rigorous standard manages to unify a multi-trillion-dollar global market.
And, the concept of unification or standardization is the linchpin of this entire discussion. Knowledge is always most valuable when you can apply it to the broader economic reality.
Absolutely.
And understanding the specific mechanisms of these BOMA standards reveals the foundational logic of how commercial property generates revenue.
So why does this matter to the person listening right now?
Well, whether you are a founder looking to sign a 5-year lease for a startup, or a portfolio manager analyzing a commercial real estate investment trust, or just an interested observer trying to understand the built environment.
Yeah.
This invisible ruler dictates the economics of the physical world around you.
So let's start with the architect of that invisible ruler, BOMA.
Right.
It stands for the Building Owners and Managers Association International.
That's a mouthful.
It is. But when you dig into the standards they publish, it's clear this isn't just a casual set of best practices.
No, definitely not.
This is the definitive methodology used globally to measure office buildings, retail malls, and industrial properties. The explicit purpose of BOMA, as outlined in the text, is to standardize how rentable area is calculated.
Exactly.
The goal is to ensure that landlords and tenants are measuring space the exact same way. But let's look at the inverse of that for a second. If this standard didn't exist, we'd essentially be operating in a metric vacuum.
A metric vacuum is a great way to describe it. To truly appreciate why BOMA exists, you have to model out the chaos of a market without it.
Let's do it. Walk us through that chaos.
Imagine you are a corporate real estate director. You are evaluating 2 competing buildings for a new headquarters.
Okay, I'm the director. I need space.
Building X tells you they have a 20,000 square foot floor plate available. Building Y across the street tells you they also have a 20,000 square foot floor plate.
So on paper, they look identical.
Exactly. But without a standardized methodology, landlord X might be calculating that 20,000 square feet by measuring from the extreme outer edge of the exterior brick facade.
Wow, okay.
Including the thickness of the structural walls and the elevator shafts.
So they're including space I can't even use.
Precisely. Meanwhile, landlord Y might be measuring strictly the carpeted livable space inside the office.
So I'd be looking at a spreadsheet comparing 2 completely different physical realities.
Right.
I might sign a lease with Building X thinking I'm getting a great deal on price per square foot, only to move in and realize 1,000 square feet of my leased space is trapped inside a concrete elevator core.
Which you obviously can't access.
I can't put a desk in an elevator shaft.
Exactly. It completely destroys market transparency. The commercial leasing market would devolve into a landscape of constant forensic auditing, endless litigation, and just profound inefficiency.
That makes total sense.
Every single lease negotiation would require an independent team of surveyors just to agree on the basic facts of the physical space. That is why the framework emphasizes its core principles so heavily.
Which is calculating these areas to make rent fair and consistent.
Yes.
And I think we should clarify what fair means in this context, because it can be a loaded word.
It can.
Fair does not mean cheap.
No, it doesn't.
It doesn't mean the landlord isn't turning a massive profit. Fair simply means universally understood. It's about establishing a common geometric language so that when a contract says 1 square foot, both the buyer and the seller agree on the atomic definition of that space.
Precisely. Standardization is the bedrock of institutional trust. When a global investment firm buys a billion-dollar skyscraper, they aren't going in with a tape measure.
Right, they aren't pacing out the floors.
They're relying on the fact that the building's rentable area was calculated using BOMA standards.
Yeah.
It guarantees the integrity of the asset's financial profile.
Which brings us to the actual vocabulary of this language. The framework breaks commercial space down into 3 fundamental categories. I view this as the trinity of commercial real estate.
It's a trinity like that.
You have to master these 3 definitions before any of the financial models make sense. Let's start with the first and arguably the most intuitive category, usable area.
Usable area is exactly what it sounds like. The framework defines it as the actual physical space that a tenant can use.
It's the space where you can close the door.
Yes. It is the exclusive private domain over which the tenant has total control.
The examples provided in the documentation are pretty straightforward. Your private office rooms, your internal meeting rooms, your dedicated storage closets.
Great.
If you lease a raw space and you build out a reception desk, an open-plan bullpen for your sales team, a glass-walled conference room, and a small IT server closet, every single inch of that internal build-out constitutes your usable area.
To ground this, the framework utilizes a baseline numerical example that we can follow.
Let's hear it.
We are asked to imagine a company that requires an office floor area of exactly 1,000 square feet.
Okay, 1,000 square feet.
In this specific scenario, if you map out the perimeter of that private workspace, the physical footprint of the tenant's daily operations is 1,000 square feet.
So that's the raw material.
This is the starting variable of the entire commercial real estate equation.
Yeah.
It is the raw material, yeah.
Right, the raw material. I need 1,000 square feet for my team, so I find a 1,000 square foot space. Now, if we were renting a residential apartment, the math basically stops there.
Usually, yes.
But in commercial real estate, you don't just teleport directly into your private office. You have to navigate through the building to get there.
You do.
And that introduces the second element of our space trinity, the common area.
The shared domain.
Yeah.
The documentation explicitly defines common areas as spaces within the building that are shared by all tenants.
So what does that look like in practice?
These are the critical infrastructure zones that enable the building to function as a multi-tenant ecosystem.
The examples here are the spaces we interact with constantly but never claim ownership over. Hallways, elevators, staircases, washrooms, and the main lobby.
Right.
It really forces a perspective shift on how you navigate a high-rise. Think about it. The moment you step out of your private 1,000 square foot office and into the corridor to walk to the shared restroom, you have transitioned from your usable area into the common area.
You're utilizing a shared utility.
Exactly.
If we connect this to the bigger picture, this is where the economic reality of commercial property comes sharply into focus. The framework provides a simple continuation of our baseline example to illustrate this.
Okay, let's build on the 1,000 square feet.
Let's assume that on this specific floor, in addition to our tenant's private space, there's a total common area of 500 square feet.
Okay, 500 square feet of common space.
Right. This encompasses the floor's shared elevator lobby, the communal hallway connecting the suites, and the shared washrooms. Now, if we look at the financial architecture of the building, we have to acknowledge a hard truth. Those common areas require immense capital to build and maintain.
Absolutely they do.
Yeah.
I mean, the marble floors in the lobby have to be polished.
Yes.
The high-speed elevators require really expensive maintenance contracts. The communal washrooms have to be cleaned and stocked daily.
Someone has to pay for the soap.
Exactly. The HVAC system has to pump climate-controlled air into those shared hallways 24/7. None of that is free.
No.
And the landlord is not operating a philanthropic organization dedicated to providing beautiful public spaces.
Exactly. The cost of that infrastructure must be recouped. And this leads us to the core thesis of the BOMA methodology. The text states it quite plainly.
How so?
In commercial buildings, tenants do not only pay for the office they occupy, they also share the cost of the common areas.
That is the crucial shift.
If you want to understand commercial leasing, you have to internalize this paradigm. You are not just renting a box. You are leasing access to an entire vertical city.
A vertical city, I like that.
And therefore, you are financially responsible for a proportionate share of the civic infrastructure of that city.
Which perfectly sets up the final piece of the Trinity. We have the usable area, your private box, we have the common area, the shared infrastructure, and when you combine them, you get the third category.
The bottom line.
The only number that ultimately dictates the size of your monthly check. The rentable area. The framework defines this simply as the area the tenant actually pays rent for.
And the equation is fundamental. Rentable area equals usable area plus your share of common area.
Rentable area equals usable area plus share of common area. That single equation drives the multi-trillion-dollar valuation of the global commercial real estate market.
It really does.
I want to pause and really look at the implications of that equation, because it's a profound realization for anyone who hasn't negotiated a commercial lease before.
It catches a lot of people off guard.
When you sign a contract for a suite on the 40th floor of a skyscraper, you are legally obligated to pay rent for a literal fraction of the elevator cab you ride up in. You are paying an ongoing monthly premium for a microscopic sliver of the granite security desk in the ground floor lobby.
That's entirely accurate.
The mathematical square footage that you are billed for is always going to be larger than the physical footprint of the office you can actually walk around in.
And this presents the central logistical problem that the framework is designed to solve.
Which is what?
Proportionality.
Mm.
If you have a 20,000 square foot floor plate with 10 different tenants of varying sizes and 5,000 square feet of shared hallways and washrooms, how do you mathematically divide that shared space?
Right.
How do you determine an individual tenant's specific share of common area?
Because if I'm a massive law firm occupying half the floor and you are a solo consultant in a tiny 500 square foot suite next to the fire stairs, we obviously shouldn't be paying the exact same amount for the hallway maintenance.
Of course not. The burden has to scale with the footprint.
So how does the standard handle that?
The distribution of the shared space must be strictly proportional to the amount of private usable area a tenant controls. The larger your private domain, the heavier your usage of the common infrastructure is assumed to be.
That makes logical sense.
And therefore, the larger your share of the common area costs. To achieve this proportional distribution mathematically, the framework introduces its primary mechanism, the load factor.
The load factor. I've also heard it called the add-on factor in the industry.
Yes, load factor or add-on factor. It's the magic multiplier. This is the mathematical gear that makes the entire BOMA system function.
So how does the math work?
The documentation states that the load factor distributes the common space among tenants, and it provides us with another incredibly elegant formula to calculate it. Load factor equals the total rentable area divided by the total usable area.
Okay, let's take this slow. Load factor equals rentable area divided by usable area.
Let's break this formula down step by step, because applying it requires looking at the building on a macro level first. Before a landlord can determine the final rentable area for your specific individual lease, they must first calculate the overall load factor for the entire floor.
Or in some cases, the entire building, right?
Exactly.
Let's map this out using the baseline scenario the framework provides, which it literally calls the easy example.
Good place to start.
We'll construct the financial model for a single floor of a standard office building. Imagine we've measured every single private lockable office on this floor. If we add all those private spaces together, the documentation gives us a total usable space for the floor of 10,000 square feet.
So 10,000 square feet represents the aggregate private domain of the floor.
Exactly. Now we measure all the shared infrastructure on the same floor. The elevator lobby, the corridors, the communal restrooms. The text sets this total common space at 2,000 square feet.
To find our first variable for the load factor formula, the total rentable area of the floor, we simply combine the two. We add the 10,000 square feet of usable space to the 2,000 square feet of common space,
10,000 plus 2,000.
which yields a total rentable area for the floor of 12,000 square feet.
Now we have our macro numbers. Total rentable is 12,000. Total usable is 10,000. We plug these into the BOMA formula, rentable divided by usable.
Right.
We take 12,000 and divide it by 10,000. The math is simple. 12,000 divided by 10,000 gives us a ratio of 1.20.
Which is commonly expressed in the industry as a 20% load factor.
20%.
This 1.20 multiplier is the translation rate between physical reality and financial obligation on this floor. It dictates that for every 1 square foot of private space a tenant occupies, they must financially support an additional 0.20 square feet of the building's shared infrastructure.
Okay, let's bring it down to the micro level and see what this actually does to a tenant's budget. You are a business owner. You find a suite on this floor that perfectly fits your team. You walk the space, you measure the inside perimeter of the drywall, and it is exactly 1,000 square feet of usable space.
In a residential model, your financial liability would be capped at that 1,000 square feet.
But in the commercial BOMA model, the landlord applies the multiplier. They take your 1,000 square feet of usable space, and they multiply it by the floor's load factor of 1.20.
Let's do the math.
1,000 multiplied by 1.20 equals 1,200 square feet. That is your final rentable area. That is the exact number that goes on the lease document.
As the framework neatly summarizes, the tenant pays rent for 1,200 square feet, even though they physically occupy only 1,000 square feet.
The psychological disconnect here is fascinating to me. From the tenant's perspective, you walk into your office every morning. You see exactly 1,000 square feet of carpet.
Right.
You arrange your cubicles and desks to fit perfectly within that 1,000 square foot box. But your monthly invoice from the property management company clearly states you are paying a negotiated rate per square foot for 1,200 square feet. You are essentially paying for 200 square feet of ghost space.
But from the landlord's perspective, it's not ghost space at all, is it?
Well, no.
It's highly tangible. It's the tile in the bathroom, it's the carpet in the hallway,
It is tangible.
and more importantly, it is entirely necessary for your business to function. You cannot operate a modern enterprise without access to that infrastructure.
Fair point.
The 20% load factor in this example is actually quite standard for a conventional office building. It represents a fairly efficient balance between private revenue-generating space and necessary common amenities.
Okay, so that's the baseline.
But the framework doesn't stop with this baseline. It immediately introduces a second scenario, titled the Real Example Office Tower. And this is where the strategic impact of architectural design on a tenant's balance sheet becomes glaringly obvious.
Let's escalate the scale. We are moving out of the standard office park and into a premium high-rise office tower. The framework sets the parameters for us. We are now analyzing a much larger floor plate. The total building floor size is 20,000 square feet.
A significantly larger footprint. Now, let's look at the infrastructure allocation. The documentation specifies that this floor features a massive lobby measuring 3,000 square feet and an extensive network of corridors totaling 2,000 square feet.
Wow, okay.
Therefore, the aggregate common area for this floor is 5,000 square feet.
So we have a 20,000 square foot total floor. We subtract the 5,000 square feet of common infrastructure, which leaves us with 15,000 square feet of total usable space for the tenants.
Now, we run the macro calculation again. Rentable area divided by usable area.
We take the full 20,000 square feet and we divide it by the 15,000 square feet of usable space. 20,000 divided by 15,000 equals 1.33.
We're at 33% load factor.
A 33% load factor.
This is a massive structural shift in the economics of the building. We have jumped from a 20% multiplier to a 33% multiplier.
That feels huge.
To understand the severity of this shift, let's apply it to a prospective tenant in this new tower.
Let's assume a mid-sized firm is looking to lease space in this premium tower. They do their space planning and determine they need exactly 2,000 square feet of usable space to fit their employees.
Okay, 2,000 square feet usable.
The landlord takes that 2,000 square feet of physical footprint and applies the 1.33 multiplier. 2,000 multiplied by 1.33 equals 2,660 square feet. Their rentable area, the number they actually pay for, is 2,660 square feet.
Let's perform a comparative analysis on that delta. The tenant requires 2,000 square feet of operational utility. They are being billed for 2,660 square feet.
That is a 660 square foot premium.
They are absorbing that premium purely to subsidize the building's common infrastructure. To visualize that, 660 square feet is roughly the size of a spacious one-bedroom urban apartment.
That is staggering when you frame it like that. Every single month, this company is paying the equivalent of apartment rent in a premium high-rise, and they can't put a single desk, server, or filing cabinet in that space.
It's pure overhead.
And the reason they are paying that massive premium isn't because their office is any better. It's directly tied to the architectural choices of the developer. The framework specifically highlighted that 3,000 square foot lobby.
Exactly. The geometry of the building is dictating the financial exposure of the tenant. A 3,000 square foot lobby is a grand, sweeping architectural statement.
Right, you want to impress people when they walk in.
It is designed to impress clients, project corporate power, and justify a premium identity for the building. But mathematically, that grand entrance radically inflates the total common area,
Which drives down the ratio of usable space.
which mathematically forces the load factor up to 33%. The implication is unavoidable. Tenants in this building are heavily subsidizing a monument of architectural prestige, regardless of whether their specific business model requires it.
Which exposes a critical blind spot for a lot of businesses negotiating leases. This is a concept we could call square foot arbitrage.
I like that. Square foot arbitrage.
Imagine a scenario where a tenant is touring two different buildings in the same neighborhood. Building A advertises a rental rate of $50 per square foot. Building B also advertises a rental rate of $50 per square foot.
Okay.
To an unsophisticated buyer, these are identical costs. But if Building A is an older utilitarian building with a 15% load factor, and Building B is a brand new glass tower with soaring atriums and a 35% load factor, the actual bottom line cost to the tenant is wildly different.
Absolutely.
If you need 5,000 square feet of usable space, Building B is going to cost you tens of thousands of dollars more per year, even though the sticker price is exactly identical. The load factor is the hidden variable that controls the true cost of real estate.
It underlines the absolute necessity of rigorous financial due diligence. You cannot simply ask a broker for the price per square foot.
No.
You must demand to know both the usable area you are receiving and the building's certified load factor.
Oh.
Otherwise, you are evaluating a financial asset with incomplete data.
Okay, so the macro math makes sense. We understand how the usable and common areas are combined via the load factor to generate the final rentable number.
Right.
But if a single percentage point in that load factor can swing a lease by tens of thousands of dollars, my immediate question is who's actually holding the tape measure and what are the physical rules of engagement?
The physical rules.
Yeah. If I am legally obligated to pay for my exact physical footprint, where does that footprint begin and end?
This is where the framework transitions from abstract financial theory to strict physical engineering. The source material outlines a section specifically dedicated to BOMA measurement rules, noting them as critically important.
And they have to be.
They must be. If the baseline physical measurements are manipulated, the entire proportional distribution of the load factor is corrupted. The standards are aggressively specific about the physical act of surveying.
Let's interrogate these specific rules. The text provides 3 primary directives for where the tape measure is actually applied. The first rule dictates that measurements are taken from the inside finished surfaces of walls.
The operative word there is finished. This establishes a highly precise boundary. We are not measuring the exterior brickwork or the concrete facade of the building. Furthermore, we are not measuring to the raw structural steel studs inside the wall cavity.
Okay, so just the surface I can see.
The measurement must be taken from the final physical finish that the tenant interacts with the painted drywall, the custom wood paneling, or the plaster. The geometric boundary of the tenant's financial liability begins exactly at the point where the usable space physically terminates.
That feels like the most logical rule. You can't put a filing cabinet inside the drywall, so you shouldn't be paying rent on the volume of space occupied by the insulation and studs.
Exactly.
But the framework immediately complicates things with the second rule. It states that when dealing with exterior walls, measurements are taken to the glass line of windows.
The glass line distinction is a fascinating piece of geometric standardization with massive financial implications.
Break that down for us.
Consider the architecture of a standard commercial office window. You have the interior wall surface. Then you typically have a windowsill, a heating convector unit, or an aluminum mullion frame that might recess several inches, sometimes up to a foot, into the structural envelope of the building before you actually hit the physical pane of glass.
Wait, so the standard is dictating that the invisible boundary line pushes past the drywall, over the windowsill, and goes all the way to the pane of glass itself.
Exactly. By specifying the glass line, the methodology dictates that the deeply recessed volume of a windowsill is officially classified as the tenant's usable area.
Even though I can't use it.
This is true even if that space is entirely impractical. You obviously cannot stand on a windowsill or place the desk flush against the glass if there is a heating unit in the way.
Yeah, it is an incredible detail. Let's think about the scale of that. If you add 6 inches of depth to the perimeter of a room, it doesn't sound like much.
No, it doesn't.
But multiply a 6-inch deep window recess by hundreds of windows, wrapping the perimeter of a 20,000 square foot floor plate. Then multiply that extra square footage by 50 floors in a skyscraper.
The numbers add up quickly.
You are suddenly talking about thousands upon thousands of square feet of invisible, unusable space that is legally categorized as usable area. At $100 a square foot in a prime market, measuring to the glass line instead of the drywall could literally generate millions of dollars in additional asset value for the landlord over the lifespan of a building.
It is a perfect example of how granular engineering standards translate directly into macroeconomic asset valuation. The precision required by a surveyor to map the exact glass line of a complex curtain wall facade is substantial, precisely because the financial stakes are so high.
And then we get to the third measurement rule, which absolutely bends my mind.
The shared walls.
Yes. When dealing with interior spaces, the framework states that measurements are taken to the center of shared walls.
The concept of the shared boundary. Imagine your business leases Suite A. Directly next door, another company leases Suite B. Separating your two businesses is a standard 6-inch thick interior drywall partition. According to the rule of measuring to the center of shared walls, the physical midpoint of that drywall 3 inches deep into the wall cavity is the invisible geometric property line.
So to be totally clear, my usable area, the space I am paying top dollar for, extends 3 inches into a wall that I can't even see, let alone use.
Yes.
I am legally renting half the thickness of the drywall, the studs, and the internal wiring separating me from my neighbor.
Mathematically, yes. Your usable area projects into the partition up to the halfway point. Simultaneously, your neighbor's usable area projects into the partition from their side, meeting yours perfectly at the center line.
That sounds absurd.
While it sounds absurd from a functional standpoint, from a systemic standpoint, it is an incredibly elegant geometric solution.
How is it elegant to charge me for the inside of a wall?
Because the mandate of the BOMA framework is total accountability. The goal is to ensure that absolutely no square inch of the building's interior footprint is left unaccounted for in the financial model.
Okay, see where you're going.
If they measured only to the inside finished surface of shared walls, the 6-inch thickness of every single partition in the building would become a geometric void. It wouldn't be usable, and it wouldn't be common. It would just be lost space that the landlord couldn't monetize.
And they can't have that.
No.
Oh.
By splitting the difference at the center line, the entire floor plate becomes a seamless, mathematically perfect grid of usable and common areas, perfectly touching at the center lines of every shared partition.
Okay, when you frame it as a seamless grid, the logic holds up. It's about maintaining the integrity of the total square footage. But the framework isn't just focused on what gets captured in this grid. It is equally prescriptive about what is explicitly excluded.
Yes, the exclusions are key.
The source material outlines specific areas not included in these measurements, and exploring what gets left out is just as vital for understanding the underlying philosophy. The first major exclusion listed is parking garages.
Excluding parking garages is a critical decision that reinforces the framework's underlying principle of fairness. We established that the load factor is designed to distribute the cost of common amenities, like lobbies and elevators, that are theoretically utilized by all tenants in a relatively uniform manner.
Right. Everyone has to walk through the lobby. Everyone takes the elevator.
But parking is a completely different operational beast. A massive underground parking structure costs tens of millions of dollars to excavate, pour, ventilate, and maintain.
Sure.
If a landlord were to classify a 100,000 square foot parking garage as a common area, it would instantly explode the building's load factor.
And the utilization of parking is highly asymmetric.
Precisely. Imagine a building that houses a modern tech startup on one floor, where 90% of the employees commute via subway or bicycle.
Okay.
On another floor is a regional sales office where 50 employees drive company cars every day. If the parking garage were dumped into the general load factor, the tech startup would be heavily subsidizing the massive physical infrastructure required by the sales office.
It would fundamentally break the proportional fairness of the model?
It would. So
Right.
by explicitly excluding the parking garage from the rentable area calculations, the framework protects the baseline tenants. It forces the landlord to treat parking as an entirely separate a la carte revenue stream.
That makes total sense. If you need 50 parking spots, you negotiate a separate contract for those spots,
Yeah,
rather than hiding the cost in the general rent multiplier for everyone else. That is remarkably equitable.
it is. Now, the second exclusion listed introduces some fascinating ambiguity.
Oh,
The framework states that building structure columns are excluded, but it attaches a critical caveat, sometimes excluded depending on standard.
this caveat implies a massive variable.
Yeah.
A structural column, especially in a high-rise, can be a massive pillar of reinforced concrete and steel, potentially 3 or 4 feet thick.
Massive.
It physically occupies floor space. It is the definition of unusable. I can't put a desk inside it. I can't walk through it. It disrupts my sightlines. Why is it only sometimes excluded?
The ambiguity here reflects the evolving nature of the standards and the negotiations between landlords and massive institutional tenants. In some stricter variations of the standard, or in older legacy buildings, these columns are entirely subtracted from the tenant's usable area
Yeah.
because they genuinely subtract from the operational utility of the space.
Right.
However, the fact that they are only sometimes excluded indicates that in many modern leasing scenarios, they are simply absorbed into the tenant's measurement.
Wait, so if I lease a 5,000 square foot open plan office and there are 4 massive concrete structural pillars right in the middle of my bullpen, there is a standard where I am paying $80 a square foot for the concrete inside those pillars.
Yes, in many applications of the framework, if the column falls within the continuous geometric perimeter of your private space, its footprint is included in your usable area.
That's wild.
The logic being that the column is an integral part of the building, holding up the very floor you are standing on. It is a harsh reality of the built environment. If you want to occupy a 50-story tower, you have to accept the structural mass required to keep it standing.
I guess so.
But again, that sometimes caveat means that for a massive corporate tenant negotiating a 100,000 square foot lease, subtracting the column displacement could be a multi-million-dollar negotiating point.
I will definitely be looking at concrete pillars differently from now on. The third and final exclusion listed is mechanical rooms. And again, it carries a caveat, sometimes treated separately.
This logic parallels the parking garage exclusion. Modern commercial buildings require vast mechanical infrastructure, massive HVAC chiller plants, electrical substations, elevator motor room. These spaces serve the entire building, so technically they are shared infrastructure. But their sheer square footage is so enormous that simply rolling them into the standard common area calculation would artificially distort the load factor, making the building's rentable metrics look wildly uncompetitive compared to older buildings with less sophisticated systems.
So the mechanical room exception acts as an escape valve for the load factor. By treating them separately, landlords can structure the capital expenditure and operational costs of these massive systems through different financial mechanisms, perhaps through separate operating expense billings, rather than blindly inflating the baseline rentable area of every single tenant.
Exactly. It allows for a more nuanced financial structuring of the asset. The rules are incredibly rigid, but these specific caveats demonstrate that the framework is sophisticated enough to handle the complex operational realities of massive commercial structures.
And speaking of complex realities, the source material explicitly acknowledges that commercial real estate is not a monolith. You can't just take one set of rules and apply it to every structure on Earth.
Right.
The text points out that BOMA has different standards for different buildings. It introduces the concept of specific measurement types.
Yes, the documentation lists 3 primary distinct methodologies: the office building standard, the retail building standard, and the industrial building standard. And it clarifies that each specific standard is meticulously tailored to explain exactly how to measure the floor space for that particular property class.
The necessity of this becomes obvious when you think about the geometry of these different spaces. Let's compare an office tower to a massive industrial distribution warehouse.
Two very different things.
Very different. A warehouse might be 1 million square feet of vast, open concrete slab with 40-foot ceilings and dozens of loading docks. It has almost zero shared infrastructure. There is no grand lobby, there are no shared elevator banks, there are no communal washrooms down a hallway. Often, a single logistics company leases the entire structure.
Precisely. Applying the office building standard, with its intense focus on calculating the proportional distribution of shared corridors and the load factor multiplier, would be entirely nonsensical for a single-tenant industrial warehouse.
Right.
The geometry of the asset dictates a different financial model, so the BOMA industrial standard adjusts the measurement protocols to reflect that reality, likely focusing entirely on the exterior perimeter and clear height volume.
And then you pivot to the retail building standard, which governs shopping malls. A mall is a completely inverted geometric model compared to an office.
How so?
Well, in an office building, the common hallway is just a transit zone to get you to your desk. But in a retail mall, the massive common areas, the wide pedestrian promenades, the central fountain courts, the food court seating, that shared infrastructure isn't just a transit zone, it is the primary product.
That is a brilliant distinction.
It is the mechanism that drives foot traffic to the individual stores.
Right. The dynamics of how shared space generates revenue for retail tenants are fundamentally different. A small jewelry kiosk in the center of a wide mall walkway is entirely dependent on the flow of the common area.
Exactly.
Therefore, the retail standard has to account for the unique relationship between the anchor department stores, the smaller inline shops, and the massive public concourses. By tailoring the measurement standards to the specific asset class, office, retail, industrial, the framework ensures that the mathematical methodology perfectly aligns with the underlying economic reality of how those specific buildings generate profit.
Okay, let's pull all the way back. We've been down in the weeds. We've dissected the geometry of windowsills, the center lines of drywall, and the structural anomalies of concrete pillars. We understand the mechanics of the BOMA framework,
We do.
but the source material concludes with a section titled Why BOMA is Important in Real Estate, and this gives us the macro perspective. Why does this invisible grid matter to the global economy? The text provides a checklist of 4 key systemic benefits. The first 2 we have thoroughly analyzed. It helps determine fair rent, and it helps standardize commercial leasing. We know it creates a common language to prevent market chaos. But the third and fourth points shift the lens entirely away from the tenant and the landlord and toward Wall Street.
Yes, the financial markets.
The text states that BOMA helps investors analyze buildings and makes it possible to compare buildings easily.
This is where the standard transcends mere property management and becomes a pillar of global finance. If we connect this to the bigger picture, let's explore the investor perspective, because it is crucial to understanding the massive scale of commercial real estate as an asset class.
Okay, let's look at it from Wall Street's view.
Imagine you are a portfolio manager for a sovereign wealth fund, or a director at a major pension fund. You are tasked with deploying capital, and you are evaluating the acquisition of a $500 million commercial high-rise.
That's a lot of money.
It is. Your entire valuation model, your projected return on investment, your debt service coverage ratios, is predicated on exactly how much revenue that asset can generate.
And the revenue ceiling of the asset is fundamentally constrained by its total rentable area, multiplied by the market rate per square foot.
Exactly. The rentable area is the foundational variable of the entire valuation. Now, if you are analyzing 2 competing $500 million skyscrapers in different cities to decide where to deploy your capital, you need absolute ironclad certainty that you are looking at an apples-to-apples comparison.
Right.
If skyscraper A's prospectus claims 1 million square feet of rentable area, and skyscraper B's prospectus also claims 1 million square feet, you must know that those numbers represent the exact same physical and geometric reality.
Because if they don't use a standard, the numbers are just marketing fiction. If skyscraper A was rigorously measured using the BOMA standard, investors know exactly how the load factor was calculated and what exclusions were applied. But if skyscraper B was measured using some aggressive, localized, proprietary standard, where the developer decided to include the subterranean parking garage, the exterior loading docks, and the structural elevator shafts in their definition of rentable area just to artificially inflate the spreadsheet,
then skyscraper B is wildly overvalued on paper.
Right.
Without the BOMA standard, an investor might deploy hundreds of millions of dollars into an asset that looks incredibly profitable based on its sheer square footage, only to discover that the landlord has hidden vast amounts of non-revenue generating, unleasable space in the fine print.
The financial modeling would just collapse.
It would. The text's assertion that the standard helps compare buildings easily is an understatement. It is the absolute bedrock of institutional trust in commercial real estate. When a financial prospectus states that an asset has been measured to BOMA standards, global investors, international banks, and massive corporate tenants all know exactly what they are buying.
They understand the underlying math.
They know exactly how the shared infrastructure is distributed. The standardization removes the geometric guesswork from a multi-trillion-dollar global market, allowing capital to flow efficiently.
And that perfectly contextualizes the final line of our source material.
Yeah.
It is widely used in commercial real estate leasing. It's widely used because the entire financial ecosystem of the built environment relies on this shared, standardized mathematical reality.
Yes, it does.
So what does this all mean for us? We started this deep dive looking up at the ceiling of a massive commercial lobby, wondering how the industry calculates the cost of such staggering scale. And the answer is the BOMA measurement standards. We have unpacked the journey from usable area, your private lockable domain, to rentable area, the larger mathematically expanded space you actually finance.
We covered a lot of ground.
We demystified the load factor, that critical, invisible multiplier that forces tenants to subsidize the grand lobbies, the high-speed elevators, and the communal corridors. We have explored how intensely specific rules dictating boundaries down to the glass line of a window pane and the microscopic center line of a shared drywall partition create consistency in an otherwise chaotic industry.
Right.
It means that every single inch of a commercial high-rise, from the grandest architectural atrium down to the smallest janitorial closet, is meticulously mapped, mathematically distributed, and ultimately monetized.
It truly is a remarkable system of applied geometry serving macroeconomic engineering. But, as we reflect on the implications of the framework we've analyzed today, it raises a complex, lingering question about the future of commercial space.
What's that?
We know from the source material that the load factor is designed to distribute the cost of shared spaces to ensure what the text calls a fair rent calculation. The foundational logic is that every tenant benefits from the shared infrastructure, so every tenant pays a proportional percentage based on their physical footprint.
Right, that's the core premise.
But as modern architectural trends evolve, we are seeing a massive shift. Landlords are building increasingly extravagant multi-story lobbies featuring artisan cafes, sprawling art installations, and massive lounge areas, purely to project prestige and attract high-end anchor tenants.
Yeah, you see it in every new building now.
When we look back at the real office tower example, with its massive 33% load factor driven by a 3,000 square foot lobby, the mathematical reality becomes quite stark.
It does.
If you are a mid-size logistics firm or a back-office accounting team that simply needs a functional, private, usable area, you have no operational need for a sprawling, museum-quality atrium. Yet, according to the rigid proportional math of the standard, you are forced to pay a heavy, ongoing premium for it.
That's true.
This raises an important question for the industry. At what point does the mathematical distribution of a common area stop being a fair sharing of necessary infrastructure and start becoming an involuntary financial penalty for a tenant? When does the load factor stop representing a shared utility and simply become a mechanism for forcing tenants to subsidize a developer's architectural vanity?
That is an incredibly sharp provocation to end on. The math itself is fair because it is standardized and transparent, but the physical reality of what you are legally forced to subsidize can feel entirely disconnected from your business needs depending on the building you choose. Well, I want to thank all of you for joining us on this deep dive into the hidden geometric mechanics of commercial real estate. The next time you walk through the heavy glass doors of a massive office tower or step into a high-speed elevator, I guarantee you will look at that grand lobby, those shared hallways, and even the structural columns with a completely new perspective.
You definitely will.
You are not just walking through a piece of architecture, you are navigating through a living, breathing, monetized mathematical equation. Keep looking for the invisible rules shaping the world around you, and we will catch you on the next deep dive.